Right,
I feel like I have an obligation not
you're
to.
rolling.
It is slightly disheartening when you're giving a presentation and your professor falls asleep.
Now, thankfully, we haven't had presentations of the type I'll mention, but there are some presentations that deserve to be fallen asleep.
That is true. Student presentations are sometimes.
We've done a fair job, I think. I mean, there's some issues with presentation style and maybe a little bit more preparation and whatnot throughout the semester, but I think we haven't had anything that was sleep-worthy.
Just you things?
Do you want something like that?
Like the worst.
I can.
Like one contact
I
lens
would
like that?
fall asleep during.
My goodness, like,
No,
you're
if
supposed to
there's
help
something
the
I can fall
technology.
asleep
People
during,
like
I'm just
grabbing
looking for a
slides
reason.
from their website
Trust
and
me.
shit. Like, this
I'm
technology
looking
is
for a
great
reason.
because, you
Do you want
know,
us to help you?
advertisers on the Jumbo. It's like, oh,
I don't
great.
mind. You
I'm
might
learning
mind.
so much about this technology.
They're just trying to.
If we can agree
Yeah.
on it beforehand, then you and I won't know.
Yeah, we
It's my screen.
Yes. So it's probably off to the right or off to the left instead of mirrored. So what are you using to present it?
PDF and the virtual machine.
Okay. And
It's the Windows and Avanti. Now it's showing the Avanti screen, not Windows.
Is Windows or Ubuntu the virtual machine?
Windows is on virtual machine.
okay. So then we need to change settings in Ubuntu. So we can do that using xrndr, or we can go through the graphical. Right, that's okay too. Okay, so inside the control panel or something along those lines, there should be a display option. I guess that's probably the more kosher way to do these things. There's more control if you use xrndr.
And what much more way to break it?
Just set the size you want and
Options of
set
Windows or
settings.
Avanti? In options of Windows or
It would be inside the Ubuntu options, right? Because we're seeing Ubuntu on both. So my suspicion is that in Ubuntu the screens are set up differently, and your virtual machine is only on one screen, right? So you need to make them show the same screen. So if we go into display, we should see a nice little graphical thingamajig that lets us control this. Okay, see, this is exactly it. They are two separate ones, just drag one over the other. Just click and drag. Just drag one. And okay, it's not to mirror. This is trackpad control. There we go. That's what you want. Now that should do it. Okay, there we go. So before we get started though, maybe wait another minute
Come
or
on,
two.
they're 5 minutes past.
They are, but we're missing a third of the class.
They still have another 15 seconds until like 5 minutes.
Okay.
Admittedly, it's not too hard to miss a third of the class when the class is small.
Yeah.
I know.
It's
but-
more discouraging when the class is like 100 people and then you're missing like 30% of the class.
It's also really discouraging when it's like 5 people and there's 3.
Oh yeah.
So the third project is posted, although the template isn't available yet. I'm adding a little bit more to it. I've had to kind of shortchange you all in order to satisfy my undergrad, so I'll shortchange them a little bit for the next few days and actually get that stuff done for you. But the template should be available shortly. The description is up there. It should all be understandable. You could probably even implement it just by changing the demo yourself. It's not that hard, I think. So awesome. Yeah. And I guess, what else do we have to cover? So I asked for suggestions for papers, but it looked like what most people really wanted was for me to put up a list of papers and for people to volunteer. So that's happened, mostly. We have all but one selected already. So one more volunteer will have to decide whether they want to present a debugging paper next week or a paper on undefined behavior and optimizations at the end of the semester.
The Thursday thing? Somebody's taking Thursday?
Somebody took Thursday. I got an email right before class that said somebody would take Thursday.
baked cookies goods still stands?
It might. Now, I did say there was a deadline of Saturday night for that, but I might still do that anyway. Because the idea there was that baking takes up less time than very busy baking, and this week is rough. This month is rough.
Good, make your work hard.
I'm not sleeping, that's what it means. Is that all we need to cover? Is there other stuff? Yes. So for those who haven't been thinking about what they want to do as a term project, your project is really short. Really, really short. I think it should be doable in a matter of hours. There are maybe 2 corner cases that have to be thought of, I think, max. And otherwise, it should be pretty easy. It's just the efficient path profiling stuff, which we've talked about before. The algorithm is listed in the paper that I've linked from the course description.
Wait, are you just talking about the project number 3?
Yes. So I'm context switching a little bit too rapidly.
I didn't know if it sounded, I thought you were saying expecting final project.
Yeah, I started out with that because we're going to come back to it.
Okay.
Yeah, motions within motions. So I don't expect to take up too much of your time. You need to start thinking about your final projects at least. I'd like to have proposals in by next Thursday. A proposal is just a 1-page suggestion saying, I think this is interesting. Here's why, and here's what I'd like to actually attack within that. Okay? This is the kind of thing that I can help you with as well. Now, when I asked for suggestions for papers, I didn't get a whole lot of response. I've got topics people can work on, but it's always easier if I know there's something you're interested in first. Because that way you'll actually be interested in the project. And that's always nicer, right? It's always nicer. So if there's any paper that stood out to you and you think to yourself, I'd like to do something related to this, we can make that happen. And final projects can also be done in pairs. Right?
Threes or 4s?
Half class pairs.
I like it, I like it.
All of us working on one paper?
Group project, class project.
And then get it published, right?
A new definition for the class project.
I think that several of the things that could come out of this class would be publishable, actually. You know, maybe not in a top tier conference if we want to get them out quickly or something along those lines, but even just, you know, new experiments that explore some of the things that we've identified as incomplete so far are very publishable. And you all may be surprised about that, but I hope that will become a little bit clearer even as we go through today's paper. For reasons that some of you have noticed and some of you will start to see as we really dig into this. But you know, I'd like to have things in by next Thursday in terms of proposals. That's the official deadline that was listed on the schedule. Maybe I'll make that slide just because some of the other deadlines have already slid. But you want to have enough time to work on your projects and have them be something that's interesting to you. So if you know, the sooner you can start your term projects, the better, because the more you can do in them, the more interested you'll be, and the greater chance you have of something that says, I've got no results, which is always cool. Question? I see a question.
No.
There was a furrowed brow.
No, I went to check my calendar and there's a whole bunch of stuff that I have no idea what it is. So, it's completely unrelated.
Yeah, okay. That's also a good reason for brow furrowing.
Look at the calendar.
All full. Other people's things.
Okay, so I think we touched on next projects, term projects, papers. Anything else we need to cover? Okay, so then let's go on.
Bring it up.
Today I'm going to present a paper titled Test Case Purification. In the process of software development, dealing with bugs is inevitable. Once a bug is found, the developers need to find the exact location of the bug. One method to find the bugs, to find existence of bugs, is unit testing. In unit testing, some assertion is used to check the behavior of the program. Once an assertion is violated, the test case framework will stop the execution of test case and reports the failure, reports some results. The current typical fault localization techniques use the such results like execution trace, execution coverage for finding the exact location of the bug. It can intuitively infer that using the omitted assertions can be helpful for a better for an improvement in the result of fault localization techniques. This paper tries to verify this claim.
So I have a question right away. How it will help? Because, okay, you have some assertion triggered. You just go to the place where it's triggered, and you figure out what the function was called. So then that's it. You look on the last line, and theoretically you might infer that the issue somewhere close. And yeah.
In the next example, we'll see how it can work. Before we move on to the purpose method, we need to be familiar with some terminology in software testing jargon. A test case is an executable piece of code to verify the behavior of the program. A test case consists of two major parts: a test input and a test oracle. A test input is the data that is being provided to the program to verify the behavior of the program, and the test oracle is responsible for this. And test oracle is a set of assertions, and each assertion is a predicate that is a binary expression that defines the correct behavior of the program. Once an assertion is violated, the test case will be stopped and the results will be reported. And a test suite is a set of test cases. A subject program is the program under test, and the program entity is the program entity represents the analysis granularity for fault localization. For instance, it can be a class, a function, or statements. In this paper, we use statements as program entity. And the spectrum of this case is the statements, is the set of the statements that have been covered by the test case. An example for assertion is assert equals of A and B, which can be used to ensure the equality of A and B. Another concept we need to be familiar with is a spectrum-based fault localization. It's a family of approach to identify the exact location of bugs. The input of these techniques is the subject program test cases, and the output is a ranking of the statements based on the suspiciousness. The more the suspiciousness value, the more the chance for statements to have bugs. These techniques execute all of the test cases and record the statements coverage. And by this, which is then, as we told before, is the spectrum of each test case. By putting this together, we form a spectrum matrix, which is used for calculating the suspiciousness.
Can you give an intuition as to what this means?
We'll go deeper
Okay.
in the next slides.
Okay.
Now let's look at an example to find out how using the omitted assertions may help to improve the effectiveness of the fault localization technique. The left figure is a subject program with 4 functions. In the third function, on line 20, there is a bug. So the third function is buggy, and because the fourth function calls the third function in its body, it is also its output is buggy too. And the right one is the test case for this subject program. It includes 3 assertions. The last 2 assertions have a call to the buggy functions. So if we execute the last 2 assertions, they will throw an exception. By executing this test case, the spectrum of this test case will be something like this. As we can see, the buggy statements, line 20 and 21, this spectrum does not emphasize anything about the buggy statements. All of the buggy statements and non-buggy statements have executed once. So it makes it hard for a fault localization technique to find the exact location of the bug. But if we replace the original test case with 3 copies of the test case, for each copy we force 2 of assertions not to throw an exception, even if the assertion is violated. By running these test cases, the first test case, A1, will fail and the last 2 will pass. The first one will pass and the last 2 will fail. And for the failing test cases, if we remove the irrelevant statements and run these test cases, we'll get this spectrum for P2 and P3, the 2 final test cases. As it can be seen, the 2 buggy statements have been executed twice, and the unbuggy statements have been executed once. And this knowledge is enough for a fault localization technique to prioritize these statements in ranking over the other correct statements. So that's why this method can help us.
So this is kind of the an empirical illustration of how the data leads to that using these spectrum-based approaches. Can either you or a member of the audience come up with an intuition for this then? Like at a high level, how would you describe this? We've got some data, some hard data that shows, we add some numbers together, this gives us something. But at a high level, any way of describing this?
No.
So they do, essentially what they do test case minimization
Okay.
using you can tell it's slicing.
Let's even suppose that we started off already having test A1 and test P2 and P3. Let's suppose we already had the minimized cases.
Right.
What is the underlying intuition behind this?
Where they intersect.
Find the maximum number of lines, the line that exists in most of the faults.
Roughly, maybe. Now, suppose
Find the
that
intersection
Right,
of
yeah.
these test cases.
it may be the case that some of those lines that are executed most commonly across the faults are also executed by all the passing test cases.
Okay.
So you remove all the ones which are being passed, like which does not contain error, and you basically have just one assertion per test case.
So essentially, some of these different, we remove all of them, we remove some other sorts of things, were some of the first approaches that were looking at comparing these coverage-based techniques, which sometimes are called spectra, sometimes are called statistical, sometimes called coverage, whatever. But if we look at just at even a more abstract notion, we can see that there's a way of examining evidence, right? We're saying if you have more of these statements executed by buggy tests or by failing tests, then that's evidence for these statements being buggy. If you have more of these statements executed by passing tests, that is evidence for these statements being correct. And then the question is, how do you combine and weigh this evidence to form a final assessment? And that, at the high level, is a notion of spectrum-based fault localization. And so this is a refinement of it, to some degree, that you've shown us.
One may say that we could remove the irrelevant statements and the original test case. But the problem is that as the spectrum is shown for the S1, some dependent statements will be kept, which for large programs, the dependent statements could be large and which is not easy to handle.
So for these assertions, the programmer has to put these assertions in almost every line of it?
These assertions are part of your test suite,
Okay.
right? So have you written, say, JUnit tests, or I'm not sure what the equivalent in
Any unit?
Yeah,
No.
yeah, exactly.
No.
Okay, so I'd recommend doing so, especially if you're a C# developer. That's a very good experience. But essentially what happens is that you've got some extra code. You've got your main code that's your program, and then you've got extra code which uses your main code and then makes some assertions about how it should behave.
Okay.
And this is your test suite.
Okay, like at this point of execution, the program should have some value like this. That's what
Yeah.
you assert.
Roughly. Right. I mean, the assertion could be basically anything.
Okay.
So they provide statistics in the paper how often developers put these assertions. So apparently in some cases they 5.8 assertions per test case. You see,
Right.
there is a table.
Right.
So it's like every single test case has at least 6. Well,
That's per
no,
that's per
well,
55,000 lines of code.
could be 6. Could be.
So have you done much in terms of development using things like stories or scenarios or some other notion of a test of some testable subset of functionality? That's essentially, if you had, that's essentially what these unit tests would boil down to, is that you've got some story and you're asking yourself, how would the program behave if this sequence of events happened? And then at every step along this way, you might say, here's what I expect at this stage, here's what I expect at the next stage, here's what I expect at the next stage, and that's a unit test. Except for a very small compositional unit of your code.
When are these unit tests usually run?
Hmm?
When are these unit tests, like this testing
Often nightly.
procedure? Is it?
So often nightly, sometimes, if you're using continuous integration, every time somebody commits.
Okay. I figured it would be.
Yeah. I mean, it depends on how expensive they are, it depends on your test suite prioritization mechanisms. You can have it set up so that, for instance, if you change one component of software, only tests related to that component get executed and things like that. Which is an entire subfield that we're not looking at. We could, but you can only do so much.
Or they generally take all the commits of one day and then test at the end of the day. The whole thing. And then
If you're using continuous integration, then it'll often be as soon as you commit, spawn tests on a machine somewhere.
I assume if any test fails, it's usually what happens.
Yes.
you know who to blame.
The idea is usually that you want to run tests to make sure that things are working before you commit.
Yeah, but it's not like, compiler warnings come up and you're like, that's okay. But, some of the test suite things are such a keeper.
So I would say that in a good development environment, and I mean that, kind of setting, not IDE, that should be shunned.
I'm sure every program developed, if compiled, is no compiled.
Well, so what generally happens is that you establish policies as to which warnings you care about and which you don't, and you follow them, or you should. The places that do follow such rules have better code, and their development costs and time are lower.
But, okay. And test suite is an ultimate thing. As soon as this fails, it is a broken, if you guys consider it. I love test suite.
Yeah, well, I mean, there are other complications. I mean, you've got issues with tests that are non-deterministic. You've got flakiness going on because of that. Tests may sometimes fail, may sometimes not. You've got issues with test dependence, where sometimes one test must run before another, but your test infrastructure doesn't know this, things like that. There are complications. The real world is dirty.
Yeah, okay.
But ideally, yes. So somewhat sidetrack. You have a notion of at least what these unit tests are.
Right.
Okay, so can we jump back in?
Now that we've established the basics, we can take a look on the framework of this technique.
Let's actually jump back out for a second, because I realized something else. Yes, let's come back to this. Do people see what the issue is in terms of the way these tests are designed? I think that may still be unclear. So could you tell me, now knowing what a unit test is, could you tell me why this existing test on the far left, can we go back another slide before we generated the, there we go. Or maybe one more, or, yes, there we go, that's the one I wanted. Can you tell me why this test wasn't as useful, based on what he presented? Or anybody, I can open it up.
This
for.
test fails, but there's something wrong with the assertion in line 9 also?
It's not that there's something wrong with the assertion so much as the test
the
would fail.
assertion fails.
Yeah, it would.
Yeah.
So
It failed in both 6 and 9.
So why is that an issue?
Maybe it reports 6, you pick 6 and you still have to fix 9 again.
The issue is you don't even know what to fix. And so
Localization.
the goal of this tool is to tell you what to fix.
Exactly.
And if you fix it and it's one bug, then that's okay. So what they want to do is make these results for fault localization more precise. And there's a problem with this test that impedes that goal. Can someone feed in on this? So we've got one test here. We've got one test. Do you want to?
Three statements independent of each other, in a sense?
In a sense, we've got one test, but there are essentially 3 stories being tested. There are 3 assertions, which means there are really 3 subtests, but we're only getting 1 unit of information out of it. And so this is kind of a waste. Why not get that extra information?
So they copy it 2 times more, and now they have 3 test cases to test this assertions.
Yeah, and so that's what, if we go forward again.
So it's like developer might decide, okay, I don't want to have 1 statement per test. I will just create
And in
one
practice, they don't.
bulky test that will test several things.
In practice, that happens, where you've got a story, right, and you test the story.
Right.
And you have several assertions about what should happen along that story. You know, if you're saying this is the way, this is the flow in which this component should behave, given this sort of interaction. If I've got this sequence of method calls, these things should happen. Then you've got several different assertions for how that component should behave after each method call, perhaps. Or you have something like this where you've got a few related stories and you group them together in one test. Now, there are people who would say that this is a testing anti-pattern, where you're grouping these independent stories into one test case. But at the same time, it happens in practice because grouping things together semantically helps you organize things. So there are trade-offs. There are trade-offs. Yeah.
In previous, like in the non-optimized, non-spectrum work, what would the failure look like in this test case? Would it fail at line 6?
So that's still spectrum work, but we can still look at that. It would fail at line 6, yes.
Okay,
Was
so
it the spectrum would show it failing at line 6 and 9 or only at 6?
So if if we go back to the if we go back to this slide again, so let's see the results for this one. Can we do we have just the results for this one? Do we have just the results for this one? A slide with that?
You mean T1?
Yeah.
Yeah.
Yes. Okay. Yeah. This is what we want. If we have just this text, then the information that we get says that all of these statements are executed in the failing test. And we don't know which are related to good behavior and which are related to bad behavior.
Okay.
Because we can't differentiate the passing subtests from the failing subtests in a meaningful way. We just know that the test case fails as a whole.
We cannot infer which statement was executed. We can get which statement was executed last,
I understand.
right?
We can get which was
So we
executed
get-
last. Yes.
okay,
we
we
could
get-
do that. That just tells you that something incorrect happened.
No, so assert will blow up on the line 6.
Okay.
You go, okay, assert was called max
Okay.
function. You go now to the max function and then to the max function with 2 arguments, and you see, okay, return B was the.
I think your next slide shows this information, right? Or almost. Yeah.
That's it. And
So
you're not the-
Well, no, I understand.
not really. No. So the issue is that you don't know which things are related to the failing assertion and which are not. You know where the assertion happened, but
Right.
without some deeper analysis, you don't know what statements were associated with that failure. You just know that failure happened.
Maybe this test case is easy to follow, but yeah, I might imagine that the
Yeah.
more complex test case would be.
That is, your insight, why can't we do this, is exactly the point of this paper. It's exactly the point of this paper. So we have one test case and we only get this stuff failed. These statements are associated with the failing test case. If we can break that down and see deeper, well, this sub-behavior was passing, this sub-behavior was failing, then we have more information and we have more statistical reasoning power because of that. Are people okay with the motivation now?
Yeah.
Okay.
Especially if like if you are not the one who originally wrote the code, so you don't.
Well, and remember,
know-
the technique is automated, right? The
Yeah.
technique is automated, so all it sees is pass or fail.
Yeah, I'm saying it's why this technique might be valuable. Like if you have the failing test case, but you're not the one who wrote the code originally, neither for the test case, neither for the main program, would be.
Sure.
This tool would be easier to.
And even if you did write it, if you come back to it a month later,
Oh yes.
You have to look into the test case.
I mean, that's part of why debugging is called. Okay. So we're all okay with the motivation now?
We're motivated.
Okay.
The framework has 3 major parts, 3 major phases. Test case atomization, test case slicing, and rank refinement. In the first phase, test case atomization, each failing test case with k assertions will be replaced by k new test case that for each new test case there is only one valid assertion. In the next phase, test case slicing, the irrelevant information will be removed, and in the last phase, rank refinement, based on the spectrum of the purified test case, the test case the irrelevant information has been removed from them, we re-rank the statements. Now,
I have a question.
deeper.
Like no, we are discussing, right? So,
Yeah.
So why would we just silence an assertion? Why wouldn't we just slice the whole test case into several independent test cases?
I think we'll get to that. I think the answer is, to a degree, we do exactly that.
Right.
To a degree.
So no, it's like two stages. First, we just silence an assertion as on this thing.
Mhm.
Then we already slice.
How do you
it.
slice? We'll get to this, but the prelude is, how do you slice this if you can't execute it? You can't execute it with the existing test unless you do some of the silencing. So you can't slice unless you can execute it. We'll get to that, Josh. Right.
I'm going to silence to if all of the on the assertions. In the first case, this case anonymization, the goal of this case is to generate a set of test cases for each failing test case. As we said before, for each failing test case with K assertion, K new assertion, K new test cases with only one valid assertion will be created. To undisable assertions, we can use structures like try-catch, which is used in Java for handling exceptions. In JUnit, which is the unit test framework in Java, there are two types of interruptions: failures and errors. Failure is caused by an assertion, an unsatisfied assertion, and an error is caused by a fault in a statement. In this phase, we deal only with failures, and if we face an error, we stop the test case execution.
Can anybody give me an example of what an error would be? A no pointer exception. Some runtime exceptions will be failures eventually.
Divide by zero.
Divided by zero. These are crashing bugs, which we discussed last time have the benefit of
Being easy to solve.
being relatively easier. So at least the things that they aren't targeting are a little bit easier.
After replacing each failing test case with new test cases, we recompile and execute the test cases, and we collect the coverage and we collect two information about test cases: the failing ones and the broken statements. These are the output of this phase. A broken statement is the point where a failure or an error has occurred. This could be an assertion or any other statement. Question? In the first case, in the next phase, test case slicing, we generate purified test cases. It means that we remove irrelevant statements. As you know, we can use slicing techniques to do this. We have two types of slicing techniques: statics and dynamic. In static techniques, we keep all the possible statements based on the static data and control dependency, and in dynamic slicing, we keep the statements that are truly executed. Because the results of dynamic slicing is better, we use dynamic slicing in this phase. And as you know, every slicing technique needs a slicing criteria, which is a statement, which is a pair of a statement and a set of variables to be observed. As a slice criterion, we can use the broken statements and all of the variables in that statement as the slicing criterion.
Yeah, I recommend ambiguity. So you said it's the ill-phrased
I think the ambiguity that you pointed out is that they said they do slicing to collect statements to remove.
To be removed, yeah.
Um,
And the slicing criteria is the broker statement.
Right, so they're really collecting the things they want to keep. But if you collect the things you want to keep, it tells you which things you want to remove. So it's just, yeah, it's a little phrase. So based on this description now, can you tell me why they do atomization before slicing and not just jumping into slicing?
Optimization before slicing?
Right. Which was your question, right?
Right. Well, so they figure out dynamic is better,
Okay.
so they need to execute the test at least once, but if it will fail,
Mhm.
they won't be able to execute it completely and get this good dynamic.
Right, right. So in the context of our example, we had errors on
6 and 9.
not just 6 and 9, something else, something earlier. Let's say 4. I don't know. Maybe it was, maybe it wasn't. I don't know. So the test failed at 6, and that means we never went on to observe the failure at 9. So we could never slice from it. We couldn't get a dynamic slice from it. The atomization allows us to get the dynamic slice, which allows us to then slice out the other things. So there's this two-phase process to do exactly what you mentioned. They do that. They just have to do this pre-processing first.
That's the thing, how they do that is different in the sense that they silence one, so only one assert per the test case would be executed, isn't it?
Yes?
Not silent.
So, instead of doing one assertion and making k different test cases, can they use some sort of binary search and using 2 of them, something like that, half of them?
I mean, in theory, they could silence all of them and then just use the assertions as criteria, but then they might lose the information about which are failing and which aren't. So my theory is, and this is actually one of my complaints about the paper, is that they focus more on implementation details than actual theory and benefits and so forth, which makes it very concrete, but doesn't necessarily clarify impact and reasoning why for certain things. They wrap every assertion in part to identify exactly which assertion fails. And I think they use that same wrapper to silence things, so they've got this multi-purpose wrap around every assertion. That's my thought.
I mean, can this be still re-optimized?
Probably. Yeah, I think there are several aspects of this that could be optimized. You might be able to get by with just one test. Silence everything, record which things fail, and move on. Now the question there is whether or not the assertions indicate some other semantic dependence that will cause an early assertion before you reach the later tests anyway. But in that case, there's little you can do.
So in the slice, you might have multiple, if you just did the slice without the automatized optimization, you would have multiple assertions within that slice. And silencing the assertions.
You would have one trace and multiple slices of different criteria along the trace. The way they have it set up with this atomization, they have multiple traces.
But if you just did a slice, you could have multiple assertions.
You could have multiple search criteria,
Yeah.
but you wouldn't want to do that because then you wouldn't strip out each individual test case.
Yes.
And so what they,
They just make K test cases, so they strip out or silence.
yeah.
I like the previous idea where they slice the whole test case into parts and then be more efficient. And then do the slicing. Basically, you divide a test case into k small parts,
Mhm.
and then run those k small parts parallelly, and all those k parts have a starting point.
Okay,
with a
so
concrete value given to them.
sure.
So that would be
So
more
the alternative though is just run one test, gain
it's just a
do
variant
one
of
trace.
that in
Sure.
terms of
It is. It's not clear that one would actually be better than the other, and in the context of something like unit tests, the traces are probably small enough that it makes no difference either way, realistically. It might, but it's not all that clear. It is the kind of thing that if you have atomization, you could keep those results around, and so in the future, if you encounter a bug, you could reuse the analysis, and that's where I think it becomes more beneficial. But your question is answered now. so I think we have a clear picture of the slicing.
After removing the relevant statements in this phase, we execute all of the test cases and record the spectrum of each test case. And the spectrums are the output of this phase. In the next phase, rank refinement, we rewrite the statements using the spectrums we obtained in the previous phase. I used the term re-rank because the statements have already been ranked based on a typical forticization technique, and we're going to improve that result. Rank refinement can be done in 4 steps. First, we discard the similar spectrums. Among the spectrums that are exactly the same, we keep just one of them. In the next step, the ratio for each statement is calculated using the shown formula. The beta EF is the number of failing test cases that executed the statement S, and the beta NF is the number of failing test cases that did not execute the statement S. Any question?
So describe that last formula for us, and then I actually want us to unpack this slide, because there's a lot in this tiny little section of the paper to unpack.
The ratio shows the ratio value shows us that if failing test cases show execute an statement, it's an indication that that statement is faulty. So this is this formula. What this formula does.
Okay, we'll go through that more. Maybe this is on the next slide. Is a continuation with their actual re-ranking formula on the next slide? Okay. So then let's go back and finish discussing the norm, and then we'll unpack things.
The next step we normalizes the suspiciousness that we obtain by typical verticalization technique. We normalize the values between 0 and 1. So now we have 2 values for each statement, the ratio and the norm, and both of them are between 0 and 1. In the final step, we calculate a score for each statement, which combines the norm and ratio. What this formula exactly does is that for statements in the initial ranking, if an statement is not executed by 40 for failing test cases, its rank will be decreased. Its ranking will decrease in the initial ranking.
Essentially. This formula is a little tough to understand, and I think some of the previous stuff is a little tough to understand, which is why I want us to unpack it.
After this, it says that you can take anything as 1 instead of 1 plus ratio divided by 2.
They do have some strange comments.
Yeah, they say you can get anything. I mean, anything you like.
Yeah, and I think we want to get at just why they say that. So let's back up onto the previous slide now. So this is what we saw there with the score is this is their final ranking. This is a score they give to everything, and things with the highest score will get visited first in your search for the buggy statement. Because this entire process gives you a ranked list of statements to look at. ordered by their suspiciousness, right? So this score is the new suspiciousness. So if we go back, this is how they start to reuse the results they got from an existing way of computing suspiciousness and adjust them for their technique. Now, one of the first things they do here is discard similar spectra. Any thoughts on that? Why do they do that? What impact does it have?
If you have more than one test case which is giving you the same fault, we want to eliminate the test case.
Well, okay, so if
It's
you've
my
got,
bias, maybe.
Hmm?
Well, my assumption might reduce bias towards.
okay, so why might it reduce bias?
Why, but my.
Yeah, dude, just you know, dive into that a little bit more.
So,
Does it say it's either B and F executed? The B and F is the non-executed one? And the ratio?
Not
of
41.
Okay,
Number of
so
any
we-
test cases that did not execute the statement.
That did not execute the statement.
to reduce number of executed statements.
It would,
So each, you need to, yeah, you can tell that if we have two tests that
They're executing
very similar.
similar test cases, they're executing the same bug, finding the same bug
Okay.
again and again.
okay, so essentially what this is doing, the first thing we can ask ourselves is, what is this doing? And then we can reason more concretely about the impact. If we think about what this is doing, it's saying, if two tests execute the same statements, then we'll only use one of them. Okay, so the idea is if they have the same coverage, the same spectra, right? If they execute the same statements, then we'll only use one of them.
How could that happen? How would you generate two test cases that are identical?
Are the test cases identical? Do they have to be? All we know is that they execute the same statements.
Oh, I see. Okay. So you could have two test cases that are different, but their execution happened.
The only different assertions, are you talking about the purified test cases?
All of this is tied to the purified test
Right,
cases.
so-
Re-ranking is only about the purified test cases.
Okay, so the statements they execute are the same, only the assertions are different.
Not exactly. So this is post-slicing, right? So we've got our sliced test cases for re-ranking. And there are a few different things can happen here. One of the reasons that you can have two tests that execute the same statements is that they execute the same statements with different data. Right? Because the data affects the outcome for some reason.
Like Mac's statement with different arguments.
Okay, yeah, Max statements, different arguments. Max, you probably have some different control flow. But you could test boundary issues with Max and follow the same control flow. This is true. So you could have, something which, two statements that are, or two numbers that are very far apart and two numbers that are right next to each other. And you could test both of those, they could follow the same control flow. Or you could have something like computing a function like a number squared or something like that. So something like this where the numerical outcome has certain properties. So that, a negative number, if you're computing the square of a negative number, you get the same answer as squaring a positive number. There are different cases that occur, but they're based on the properties of the data, not properties of the control flow. That's one of the reasons you can do this. And one of the reasons why you would have two tests that execute the same statements. The other case is where you're executing these same statements in a different order, potentially, right? Same statements, but a different order.
They also removed?
They would also get removed because they're the same spectrum, the same coverage properties.
Okay, because you're just looking at the path to get to the bug.
Right. So the case where this makes sense is if two test cases are essentially the same, and so they cause the bug in the same way, maybe you want to get rid of them. I'm not sure if that's true or not. But if you have two test cases that behave differently in a semantic way, maybe those two different test cases with the same spectra still indicate additional evidence. It's not clear to me. So I don't know whether this is a good thing or not. It might be, it might not be. I can't justify it. And this is the kind of question that I want all of you to continue to think about as well. You know, when you see something like this in a paper, ask yourself, does this make sense? How can I justify this? What problems can I see arise from this?
They should be the ones to justify.
They should. There are many things in this paper where they say what they did, and they don't say why at all. That is one of my big complaints. And that's one of the things we have to unpack throughout this tiny quarter of a page section that has no justifications. Phase 3 of their system has no justifications at all.
Because they did it this way, it worked.
And we'll talk about that. We'll talk about that.
How can they justify this?
Say why they did it.
Why do you use this particular?
If you didn't, they have a table 3 with like 6 tests, and all 6 have different suspicion criteria.
So not only that, there are an infinite number of possibilities of ways to achieve a similar rank refinement approach, and I can think of a few, which we'll get to, that would be simpler and easier to justify, but that they didn't do, and they didn't compare against. They didn't even mention. And they should have. But before we talk about all that stuff, let's just unpack the rest of the stuff on this slide and try to figure out what it means. So when we look at this ratio, what is this ratio telling us? I think you gave us a reasonable intuition for it, but if you could go back over that a little bit. So what are these beta EF and beta NF again?
Beta EF is the number of failing test cases that executed the statement test, and beta NF is the number of failing test cases that did not execute the statement test.
So the first thing we ask ourselves is, why aren't they considering passing test cases? And I think there's an easy explanation for that.
They don't have bugs. The passing test case doesn't have bugs.
They don't have bugs, and as a result, they aren't part of the refinement process. The refinement adds information based off of splitting the failing test cases. Now, I think there is something a little bit off there, because there could be additional passing test cases as well during the refinement process that they don't identify. So they might be throwing some passing information away, right? Because if 9 had been passing, they still wouldn't have that extra information. So that's kind of weird to me. It's something else that gets into this, where I'm not clear about the justification for some of this. It makes sense intuitively that this information is useful, but I can tell you, for instance, that we'll see this formula again because it's just one part of the actual tarantula formula they used to do the original suspiciousness calculation. So there's some weird subtleties here that we want to come back to. But intuitively, they have this notion of the suspiciousness is the total number of failures over all of the observed executions of this statement. Or rather, that's not a good way of putting it. No.
What you're trying to say is that in order to get the same output, we can do it with simpler. We can do something simpler to get the same thing.
I think we can do something simpler to get stronger results.
Better.
So we could have used like the passing test cases to filter out things from beta and F.
Or just to add greater evidence. It's all about evidence. The evidence you can build, right, for passing or failing. And if there's passing evidence, why do they throw that away? It may have been hidden by a failing test case. That doesn't mean it's not useful.
So,
So,
if there's a test case, they remove an assert, and then it passes from there on in. All the test cases pass. Those are not looked at.
Could you say that again?
So if they split their test case into K test cases, and let's say all of them but one pass. So you
Okay.
They just throw away the past one.
they would only be looking at here with one failing test case.
Yeah, that's the only evidence they reconsider.
So even the NF, beta NF, the non-covering of S, does not include the passing test case.
No. So the issue here is that you can have some other failing test cases that don't cover S, right? So the bottom is how many test cases were there? Or how many failing test cases were there, rather?
Yeah.
And the top is how many of those failing test cases covered this statement? And that is the notion of evidence that they're using as a ratio here.
Now that depends on the test quality itself.
It does. That's another big issue.
Now, if I'm using like similar test cases, all 5 are similar,
Mhm.
in that case, this will be like.
Yes.
an issue.
And that actually is the biggest issue with not just their approach, but the statistical or spectrum-based localization techniques on the whole, is that most test suites aren't necessarily good enough. And there's actually research into things like generating new tests or generating test suites specifically for fault localization because of that. In fact, there's another paper in the context of web apps that uses symbolic execution guided toward the idea of generating tests to provide evidence for fault localization. So all of these techniques start to come together. So we've unpacked what ratio is, right? And thankfully this is our 2-hour day. What is norm?
Just escape the suspiciousness.
Yeah, that's all it is. So we've got this pre-existing score for the previous techniques. And in theory, that score could be anything, and they just say usually the highest score is the one you look at first. And so all this does is make sure that the score is within the range.
So
0 to 1.
generally, normalization is suspicious by max. It will still be between 0 and 1.
Yep, yeah.
So why are they subtracting it from them? Does that make a difference, or you could choose anyone? For example, like when we draw graphs, for normalization what we do is we use suspicion by max. It would still normalize, and the values will be between 0 and 1.
Your suspiciousness could be negative,
Okay.
right? Or your suspiciousness, it's just a score, right? The notion of suspiciousness is just a score, right? I agree that there's a scaling effect going on, but scaling effects are irrelevant when you're looking at ordering within a sequence.
And they add it actually, so this normalization does matter. In the next one, it is normalization 1 plus ratio by 2 instead of just into ratio by 2.
Okay, well, now that we've looked at the normalization, let's actually look at that. Let's look at that, because I think now we can piece all these things together.
The next step.
Yeah.
So in this case, it does matter
Mhm.
when they do a minus and min, because they are adding the normalization to the ratio. So they have normalization.
Multiplying.
In multiplication, there is a 1 plus thing, right? So you have normalization plus normalization into ratio.
But then will not have the same effect on all the statements?
So
The ratio business is a bit funky. Like, I can't justify this score, personally.
So why are they adding that stuff? If they just did a multiplication, it would still make sense, because they want to normalize the ratio. But
Yeah.
in this case, the normalization does have an impact on the final score.
Not the ordering, right? It has an impact on the final score, but remember, all this does is give you an order based on the score. So the absolute value of the score doesn't matter at all. It's just the order in which things are scored. And so if you have some initial scoring, doesn't really matter.
So can we say it is just amplifying the score given by the previous tantrum or some other technique?
Essentially, yeah, it's
Because
zooming in.
normalization 1+ ratio is
So-
giving more value to normalization. So
Yeah.
basically they are just amplifying the values
So-
which the
No, it's not amplification.
It depends. It depends on the actual original scores, on what they were. So if the original scores were all within a tight little range, and so your min was 0.9, your max was 1, then suddenly you zoom in, right, and have this fill your entire range.
Yeah.
If, on the other hand, you had a score of like 500 and -40, then you're condensing things into this range. But it's all just a scaling effect, and scaling effects are irrelevant to the order anyway. So I don't see a strong purpose for it at all. I think you could take it out, because it's just a scaling effect, and it doesn't change the order of things, and it wouldn't have any impact. At least, that's my interpretation. I'm not sure if sanity checking myself here, because I'm very sleep deprived. Does anybody disagree? And it's entirely okay to disagree as well.
You mean that normalization is not needed?
Yeah, that it has no impact on the order. Everybody's struggling through it.
Yeah, no, it makes no difference, because normally it's no, yeah. So you're saying that
Why
norm
not?
could be removed?
Hmm?
Norm could be removed, you're saying?
I think it could be. Do you disagree?
Can you go
I
back to
think
the?
that normalization increase the sensitivity of multiplication for the ranking. If the range of suspiciousness is very high,
Mhm.
then multiplying by ratio may not change the ranking.
Well, it shouldn't change the order of rankings though, right? So if I'm ranked higher than something else, whether my score is very large and the other score is very small, or they're both very, very close, the scaling factor I don't think should change the order in which their scores occur. At least not that I can tell.
Okay, can you go back to the previous slide?
Wouldn't this spread out the?
It depends. Sometimes it'll bring things together, sometimes it'll spread them apart.
No, but high values would become higher, small values would become smaller.
Oh, you mean in terms of the ratio?
You wouldn't, well,
That shouldn't really matter though, because it's all about the ordering, right?
unless you're looking at the degree.
Well, you don't look at the degree. You throw out the degree.
If you did look at the degree.
The degree is meaningless. It's just score. The degree literally has no meaning.
Well, they might think that it does have a meaning.
they say that if it's greater than 10 then
Yeah.
you have
That's
more-
the ordering. That's the greater than 10 is how many statements you have to look at. It's a different number.
Cause they,
The suspicion score is from the tool, right? They're using.
The original suspiciousness score is from the tool, and it's just a score. It doesn't have any semantic
The
meaning.
SUPS, that is from the tool, right?
Yes, yeah.
so when they go on to the next section and they say, you know, method of rank refinement, and they give a few other, formulas,
Mhm.
are they equivalent to, would they give
No.
the equivalent?
No,
Ordering?
what they're hypothesizing is that any of these could be good and they don't know.
Are
That's
they
all
giving
they're
different ordering?
Well, the others absolutely could give different orderings because we do affect the ordering. So let's go on and look at the score again. We do change the ordering here, right? We do, because we have an element of the suspiciousness, which is what's integrated into norm. You could essentially just replace norm by the original suspiciousness score.
Yeah.
And that's it, you know, and then you've got that component. And then the question is, what is this impact of the ratio? And the ratio is the additional evidence provided by the normalized, the atomized test cases, the new test cases.
So it's something like probability where you have a bias and where you have a prior and where you have something which you have observed.
A little
And we
bit,
can
yeah.
say that the norm value is a prior which you
Sure.
got from this existing tool,
Sure.
and based on your observations you say that no, actually what I observed is there is this other test case which has been failing more number of times, and I just multiply that number.
I actually
just
buy
to
that
get
argument. I
to
buy that
get a
argument.
decent score. Yeah.
That I think that makes more sense than anything they said.
Yeah.
Because they never said that. They didn't give any sort of, say a Bayesian justification or anything like that, which they ought to have done at the very least. I mean, that's exactly the sort of justification they should do in an academic paper. I still think, though, that they're throwing out the passing evidence, too. So what makes the most sense to me is you have new test cases. You didn't really have a prior and new knowledge added. You have a new set of knowledge. They should have just rerun the original technique with a new set of test cases. Why not? I can't see any reason not to, right? Essentially, they just subdivided some of their test cases. So why not just run Tarantula again on this larger set of tests? And then you integrate the knowledge of the new passing test cases and the new failing test cases in one monolithic score again. And it still integrates the additional knowledge of the failing test cases, as they're trying to do. I can't come up with a justification for not doing that. I see thinking, I see.
So, okay, we think that could be done differently.
Yeah, well, I think that would have been the baseline comparison that they did not make. They haven't shown that their technique doesn't survive this, doesn't provide a better benefit than remove the rank refinement process entirely. Cross out section 3 or phase 3 of their system. Don't bother doing it. Just rerun your original suspiciousness technique after you've done the tested, the slicing. Why do we need this third thing at all?
Will Tarantula work? Yes, it does. This is how you get suspicions.
Yeah, and essentially their ratio up there is just Tarantula for failing tests.
Can you give Tarantula 2 test cases that are identical, except for, well, pretty much identical?
Tarantula doesn't care about what your test cases are. It just looks at what statements they covered and whether or not they passed or failed. We'll talk about this when we look at the formulas, when we get to it.
If you give Tarantula, does that only work for one test case, and then it gives you suspicion value of those things?
It works for a test suite.
So
It's a statistical technique. All of these spectrum-based approaches are statistical techniques. So the more evidence you have, the more test cases you have, the better.
and it does combine all that information.
Yeah, and we'll see this because I know that these are coming up, but we've been stuck on unpacking these things. But does this at least get the point across that it's not clear what's going on? I do like the justification that they could be using some updating of knowledge based on priors. That's a good observation that they should have made. That's a really good insight. I still don't know that it's necessary though, because I think that there's more knowledge they're excluding. Anyway, so perhaps we should go on and see the rest of this.
Moving into the next part, let's take a look at the subject programs they used for evaluating their work. 6 open source projects have been used with these key features. The 40 versions from the original ones have been created by a mutation testing tool named PIT. And the minimum number of mutants they used is 347. In the paper, it's been mentioned that a minimum number of 300 would result in a stable localization result.
So they mentioned something about that. The assertions per test case can be up to 1.
Did they?
Yeah.
I missed that.
What was assigned with the
Does somebody else remember?
below the image, below the table itself. they
Right.
mentioned.
What did you say?
the number of assertions per test case can be less than one, because in the first case, it says that number of test cases are 343, and the number of assertions are 335.
Yeah. Okay, yeah. It's just because they're only looking at JUnit assertions. Yeah, so essentially if there are any non-JUnit assertions, they don't consider them. That's.
So I have a comment regarding the way they created their faulty programs. So they created using mutation, right? And before we read another paper on mutation analysis where they found out that test suites not always very good in the sense that even when you apply mutation analysis, the test suite won't be able to catch all the bugs.
In general, they can't guarantee it, yeah.
Right.
Yeah. Mutation analysis, well,
Therefore, it's we will even with this test purification, we will still miss many bugs.
yeah, so I think that's the observation you saw came from a mutation analysis paper, but it's somewhat orthogonal to the fact that they're using mutation analysis, or mutation testing tools. But the fact that test suites can miss them, absolutely.
Right. Which kind of diminishing the the potential usefulness of the test purification, right? Because it
does.
cannot.
It means that you need to have a strong enough test suite to actually provide you the statistical evidence. If you don't have enough failing tests, if you don't have enough passing tests, you don't have any evidence. This is true. And that's one of the biggest, do you have enough tests is one of the biggest issues. You need evidence. And it's possible that your test suite isn't even strong enough to recognize the failure. In which case, you've got failing evidence of some reported bug.
What if there is bug in the test suite itself?
That happens. Yes. In fact, updating tests, you can essentially view failing tests because of refactoring changes as bugs in the test suite as well.
We need test suites for the test suites.
That's what the program is, right? In a sense, the program itself is to a degree a test suite for the test suite. I mean, they synergistically drive each other as long as you've got a human in the loop. I do think there is an issue with this, with the fact that they're using mutation analysis though. They mentioned in the threats and limitations something that you'll come back to. I recall it from your slides at least, where this causes one issue. But a separate issue is that we can justify that mutation analysis can simulate the effect of real bugs. We can't justify necessarily that the mutants themselves identify the nature of real bugs in such a way that localizing mutants is the same as localizing bugs. The relationship goes one way but not the other. Or at least there isn't any evidence that it goes in both directions. Mutants can imitate real bugs, can imitate the effect of real bugs, insofar as some complex bug might cause a branch to take a true branch instead of a false branch. That doesn't mean that if you localize this simple bug, that it's the same as localizing a more complex one. So I do think there's an issue there as well with this analysis. That it exists in a body of default localization research. It's unclear whether or not the same localization power applied to mutants applies to real bugs.
Why is the number of line of code for test suite is much higher than the number of assertions? For instance, in JUnit, in each test case, we have put assertions. What are the other statements in the test suite?
Things like setup and teardown. So for instance, you're forming assertions over behavior, right? And so one of the things you might do is create a bunch of objects and then make those objects interact with each other. And then you might have a final assertion about the final behavior. And that's the sort of stuff, the boilerplate and setup and teardown and the actual behavior that you're testing that falls into the other code.
You're going to listen.
Sure. Yeah.
As I said before, a typical photocatalyzation technique has to be used in this technique. The six well-known techniques have been used, namely Tarantula, OGI, Jacquard, OGI2, and Kaczynski. Each of these techniques has its own formula, but in general, every suspiciousness formula is the function of 4 parameters. The 2 first are the number of failing test cases that executed and did not execute the statement S, and the last 2 are the number of passing test cases that executed and did not execute the statement S.
Why do we need both execute and not execute? Which is, I think, maybe where your brow furrowing came from.
No,
No?
my question was, why this complex formula in first place?
This is an abstraction. We'll look at the other complex formulas after this. This is just a generalization of for some f. All of these different formulas are some
We're
function over these
talking about
things.
this one.
We'll get to that. We'll get to that.
This one's like.
We'll get there. We'll but why do we need both the passing and the failing? And why do we need both covered and not covered? Why do we need all 4? Or at least some notion of these 4?
The passing ones will give you the evidence
Mhm.
for the test cases, for the lines which have been executed,
Okay.
and the ones which have not been executed at all in passing and failing tells us about it too.
Okay.
And-
So essentially we have notions of, we have evidence for correctness provided by how many passing test cases executed, evidence for incorrectness based on how many failing test cases executed it. But we also have notions of how strong the evidence is based on just how many tests actually executed these things or not. Maybe a statement was only executed once, ever, and so it's tough to say what that means. There isn't a large body of evidence. So this gives us a broad scale to work with.
And this table shows the formula for each test case. For instance, the SPI is exactly like the ratio formula we used.
But why they're different for every single test suite? Where did they get this formula from? From the papers of this test suite?
Yeah. No, each one of these is a different paper. So Tarantula was kind of the first spectrum-based fault localization paper, and we should probably work through a notion of what it models together. Do we want to do that? We could. Essentially, every one of them, though, is just a different model for weighting failing evidence and passing evidence. OGI has some basis on models used in biology, I believe. Jacquard is actually a standard metric that's been around since 1912, 1910. It's a standard set similarity metric. It's from mathematics, right? It's very old.
Isn't Jacquard just the number of failing cases over everything?
Essentially, it's pretty standard set similarity. But they're really all just different ways of modeling these conflicting notions of evidence. And they're all empirically justified because there is no formal semantics-based justification for any of them.
So I haven't obviously heard they even
Sure.
even heard about any of these tools.
Sure.
So will they take some logs, execution logs from the application and pinpoint where the fault is?
Relatively speaking, so all of
How
these,
they-
all
how
of
do they
these are
work?
these spectrum-based. These are the spectrum-based approaches, right? So when we looked earlier at the example and we said you get a set of tests, you've got some passing and some failing. The statements inside the failing tests give you evidence of suspiciousness, and the statements in the passing tests give you evidence against suspiciousness. That's what all of these techniques are. And so all of them return to you an ordered list based on their suspiciousness scores of, well, you should look at this statement first, look at this statement second, look at this statement third, and so on. And eventually, as you make your way down this list, you'll probably run into the bug. So what it does is it directs your search strategy through the code base. So that's the goal.
Different ways.
Okay,
Yeah,
as you,
yeah.
So there's different ways to do that.
Yep.
as
Very
you
different
said
ways.
that passing test cases are also strong evidence,
Mhm.
right? Tarantula does exactly that,
Yes.
and that's why they get good results with that.
Yes, so the strongest results tend to come from Tarantula and OCI. There are other empirical studies that have come out over the last few years that show that other techniques tend to not be robust, but Tarantula and OCI tend to behave about the same. pretty
So they are
consistently.
already the best test cases.
Yeah.
And on top of that, they have used their scaling effect,
Mhm.
and then they are saying that they get best results with the Tarantula.
Yeah.
Apparently, it was the best in the first place.
Mhm.
So
It's not just that they got the best results, it's that they saw the most improvements, I think. Using
And that's
that.
because they are using passing test cases as evidence in their formula. Whereas,
OGI does too, but OGI does pretty well in general also. I mean, in general, I think they should be using additional passing evidence from their atomized test cases as well. I think they ought to be in general, yeah. But SBI, I wouldn't expect to improve very much because you're right, SBI does not include passing information, for instance. And that's in part because it actually has some other goals in mind. It's not really intended to be used in the same cases as Tarantula, actually, because you.
also, if you look at OGI, the executed passing test case, you are taking it in the denominator with the square root, whereas in Tarantula, it would be effectively used as a numerator,
Mhm.
and it's a direct ratio. So the amplitude of effect which it has
Mhm.
is more in Tarantula.
Mhm.
And as per their formula, it is normalization plus normalized into their ratio. So this normalization plus factor is giving them the more improvement in Tarantula.
And it's an artifact of how they've constructed that extra,
Right.
yeah. Which is why it's a little bit unsettling why they give one formula and then say many others could be used, and we have no idea what's gonna happen.
Right.
And they don't compare against the baseline, which is free running. Because maybe you get roughly similar results if you don't use 3 at all, or you don't use space 3 at all, don't do any refinement, and you just rerun your original scores. Maybe both OGI and Tarantula would improve. And it's not clear. It's not clear. Yeah. Like the original Tarantula paper is a good paper to go back and look at if you're interested in these techniques in general. It's an easy read, but yeah, none of these has a rational justification. They're just models that help to weigh evidence. Anyway, maybe we can move on from the formulas at that point.
To compare these techniques, we need to define a measure. Wasted effort can be used as this measure. Wasted effort is the rank of the faulty statement in the final ranking. It simply means the number of statements that the programmer have to investigate before reaching the faulty one. And with the statements that have the same suspiciousness value, we get the average of the ranking. And it's can be formalized as case statements.
So intuitively, can someone explain this to me? What does this mean intuitively? Because, you know, essentially every single time, you know, when we go through some formula like this, that's what I end up asking something about, right? What is the intuition? Formulas are nice and all, but can we say what it means? If we can build an intuition for it, then the formula doesn't matter as much.
Less lines to look at.
Yeah, this is the expectation of how many lines you have to look at to fix a bug. Okay?
In real life, to the wasted effort you will add checking emails, going to the meetings.
Giving up.
Yeah.
Finding the experimental results of this paper. The positive column indicates the number of faults that are improved after applying the test purification technique. The negative column is the number of faults that the basic technique gives a better result. And the neutral column is the number of faults that they didn't change by applying the test purification. Table indicates that the conjunction of Tarantino with this technique gives the best result with 43% of positive results. And as the last column suggests, most of the, over 50% of the faults are neutral. That's because most of the bugs are very localized and they rank top. They ranked, for example, first in the basic technique. So test purification couldn't improve these faults because it's already optimal.
Is this the value here based on the wasted effort metric?
Yeah. Yeah. So we're looking at improvements is positive, the same is negative, or the same is neutral, and more wasted effort is negative.
So they haven't made any reference to the degree of improvement?
They go through that more in other
Yeah.
other evaluations.
What is suggested?
But this should be expected though, right? Just because more evidence gives you more reasoning power. So if you've got more tests, you've got more evidence, you should be more precise. And then the question is just, how does their funky formula come into play? And is it inconsistent with some of the suspiciousness metrics?
And the reason of negative or false negative results, they mentioned that is maybe the dependency in the between test cases, which they couldn't handle.
So, are people familiar with test dependency? The idea that one test behaving properly depends on another test? But it's essentially the idea that if I have two tests, the code for one has to run in order for the code for the other to behave correctly. And ideally, it's the kind of thing you should recognize in your slice. But in practice, there are things that exist outside of the observable system, so they don't get trapped inside the slice necessarily. And if they are tests that exist across test cases, like this thing created a file, and a successive test needs to read from that file, then it's a bit more pathological.
Why would we do such a thing with this?
This is a very good question. It happens. Don't do it. It's bad, but people do it. So in the real world, you have to live with it.
So basically, it's like several tests. It's better to keep them together, but they happen to be separated. So can we make, or we don't like very big tests that check lots of things?
Well, essentially, it is a testing smell. Test dependencies are a testing smell, just like you've got other code smells. If you have these sorts of test dependencies, they're the sort of thing you should work to eliminate, because whether or not they are a bigger test they actually are a bigger test, they might just be hidden. So, one way or another, you either need to make them independent or make them a bigger test, make that decision. But, yeah, it's, test dependency is just a hidden testing scenario.
And the next table shows the computation time for the phases, this technique. The major time-consuming phase is time slicing. That's because we use dynamic slicing, and dynamic slicing is a complex task which requires monitoring execution traces, which is expensive. And the whole time of the time of the whole process on average is 275 seconds, which they said it is reasonable because the whole process can be done automatically.
It's so misleading, this average line. Come on.
Yeah.
For example, look in the second column, original fault localization. So GXL, 5.7 seconds, and then compare it to EC codec.
Okay, so this was not an uncommon comment. This was something that was pretty consistent across the critiques for this paper. And we got about half the class to critique the paper, which is a pretty good turnout. But I think you have to weigh a few different things in mind. The question is, how much do you spend versus what you're getting? The human effort for debugging is hours or days.
No, I'm saying just average is misleading, but
Oh, I agree with that.
Yeah, so they
but
have mentioned
you look at the total and you see reasonable numbers.
Yeah.
And we have nothing against them.
Yeah, I agree that it's in general it's better to report a distribution. I don't know if people have seen this or read this paper. Probably not for most of you, because most of you are new. But there's a great paper from ASPLIS 2009, which is how to get incorrect results without doing anything obviously wrong. And it's really good. It's done by Mikowitz and Amardawan, and they had a series of papers where they looked at how evaluation could be done incorrectly. And there's also something called the Evaluate Collaboratory, which was part of PLBI a few years ago, where they look at how to do good evaluation. And in general, you have to worry about things like what are averages and what are you reporting, and is your experimental setup correct? And in general, most papers don't do that correctly at all. But if we look at just the big picture, I would say, big picture, what are we getting versus what are we spending? And even in the worst case, we're spending, what, 500, rounding up, 500 seconds total, right? And even if we were tacking on an additional 500 seconds, I would say that's worth it if you have better precision. Because reasoning about one suspicious statement could easily take longer than 5 minutes. So the human efforts are larger. They're the dominating factor.
They're also expensive if you run the company.
Yeah. I mean, people are expensive. You need to pay. Yeah.
Computers are cheap.
Yeah.
My thing is, it's a minor point, but rank refinement is two formulas. Like it's not a very, not a complicated thing, right?
It's not only not complicated. This is true. Oh, in general, you'll see that it's on par with original fault localization. It's actually a little bit cheaper for some of them. Well, a lot cheaper for some of them. But yeah, it's really, really simple.
How the hell do you run that simple thing and it takes 20 seconds?
You have to do it for every statement.
And you order that, or you need to order the statements as well. Does it do it?
That happens afterward, right? That's after you've computed the ranking, you do the reordering for the sorting. Maybe they include that in there. Maybe they include the sorting. Yeah, that's possible. Sorting the statements after doing the recomputation. But I still have issues with the fact that they're doing that at all.
Yeah.
Anyway, right, so, yeah, let's go on from these experimental results to, okay.
In conclusion, this case purification could improve the results of the basic technique with a little cost of negative results. That's all.
Okay, okay. And I should say, they did break down in a more granular fashion the notion of improvement or notion of impact on the score. And they do that on one of the following pages.
The really big graph?
Yeah, it's the big one. And so that's where you start to get a notion of the actual impact, or degree of impact on the work. But my biggest complaint about this is that they don't break down the individual steps and show the impact of each individual step in the process. That's the kind of thing you really ought to do. If you have multiple complex steps in some sort of systems process, you should break them down and show the impact of each one. And we just don't see that. We don't. And so it's difficult to tell what the meaning, what the added value of any one of their individual contributions is. This is the sort of thing, again, that all of you should try to think about when you dig through these papers. I know that most of you are still having difficulty formulating critiques, formulating this notion of digging into a problem and trying to reason about it critically as opposed to more superficially. And this is one of the skills that I really want you to get out of this, because this is what you can take with you. Reason about things critically and decide, is this something I'd actually want to implement and use in the real world? Well, you know, spectrum-based fault localization is a reasonable thing that some companies actually do use. It does depend on having a good test suite. But for some problems, that's okay. And for some problems, you can generate good test suites reasonably. Which is the case for web applications, by the way. And for others, you can't. Do you want to add in this component on top of it? Well, the first part seems very reasonable to me. The second part, I don't know if that will improve or hurt your results. Or rather, the third phase, I don't know if that will improve or hurt your results. And so that's unclear. And if you're thinking about this from, would I do this in practice? These are the kinds of things you want to ask yourself. What can I take from this? What could I apply? Okay. Let's see, did I have anything else I wanted to harp on? I guess they did also mention the threats of validity of they don't know whether or not the particular mutation operators they selected are meaningful. And that's very true as well. They used a limited subset of mutation operators, and we don't know if mutation operators at all are useful
They also
for...
take only 300 out of them.
Yeah, yeah.
Which they say some paper states that it's the ideal number.
At least they backed it up.
Yeah, that's something. That's something. And you know,
They only applied one mutation, right?
No.
Did they apply more?
Several.
Did they apply only 6 mutations?
yeah.
I didn't know if they applied.
Well, so 6 times 300 is
1800. 300 for each.
that's what the math says.
Okay.
Guessing?
That sounds about fair.
That's speculative and might not be true, but the numbers add up. That could be entirely coincidental. I don't remember. I didn't read that part closely enough, and I should have, but yeah. Any other comments about this? I mean, it is interesting.
It was kind of easy to read.
It was. It was easier to read than some of the others.
They had a lot of space to explain.
They did, and some of their pictures are awfully large.
Yeah.
Look
like they tried to fill a lot of things.
Yes, I agree. I agree. And I would love to see figure 2 where they had their framework diagram shrunk down a lot and added in things like the justification, which you deciphered after the fact of what their formula was supposed to mean, and better yet, some experiments that actually validate anything they're doing. I mean, the first part I think is great. The atomization and the slicing part is great. I think the reason they have these other parts in there is because the first part didn't feel like it was enough for a top tier publication. And so they added in something that looked good, but it isn't well validated enough for me to say that it actually means something. It might have been, I mean, they got it published, and that's something to take from it. You can see how they added in some added perceived value to get this published, but I'm not sure whether that was the right thing to do.
This conference is well known.
FSC is a top tier software engineering publication.
I do have a question.
Okay.
About next paper.
Okay.
What is golden implementation?
Aha. If you read the paper, this will become apparent.
It seemed to be
Um,
kind of a given, just quickly reading over it.
For instance, a lot of the time when you're implementing a standard, there's a reference implementation. Maybe it doesn't do everything you want, maybe it isn't as efficient as you want, but there's a reference implementation of correctness or for validating things.
Okay.
Right?
I heard it's about like MP3 standard, for example.
Sure.
There is reference implementation of it.
Yeah, and for various web standards as well, there are reference implementations. And especially for embedded environments, there are often reference implementations of things. And that's one of the focuses of that particular work. It's an interesting paper, but we'll get to that. We had a volunteer right before class for
the lucky one.
Dorso.
Oh, so nice.
So yeah, I'm surprised. I thought I was going to have to present that one, but saved by someone else not wanting to present a later paper.
In case no one comes up, can you present it?
I know the paper. I can present it. I'm fully qualified to present any of these papers.
No. I meant that if no one shows up, in the sense no one takes responsibility of presenting the paper, and then.
We had an extra slot,
Oh,
so if
gotcha.
no one showed up, I would have presented that one.
Okay.
Depending on which paper you take, I will either be presenting something next week or at the end of the semester. So you'll need to let me know by the end of the day which one you're going to do, because otherwise I'm going to be presenting something at the end of the semester. Yeah. One of those perks. But yeah, I mean, essentially, I would be presenting one of these things that isn't taken, just because of the way things fall out. Okay. Any other questions? Again, project 3 out-ish. Discuss term projects with me. If you don't have an idea of what you want already, we should refine those. Discussing with me is fine. I know this is something that none of you really like to do, based on the lack of questions that I get and the flurry of questions that you seem to give each other and previous students who've taken courses. But you can talk with me about projects that you want to do for a term project. That's fine. So we should work through that. Okay. Yeah. So if there's nothing else, we can get out of here. I'll go grab lunch. Oh, excellent. Okay. Yeah, I can do that.
Are we getting picked up? Is there a class interaction?
In this one, yes. Apparently, the other one, no.
They do have questions for you.
Okay.
Questions for you, just as fast.
Finally.
Not for projects.
No, they're final project.
Oh, yeah.
Which is also equivalent to my research.
Which is good. Yeah, I mean, if for those of you who are doing research, having things coincide